Welcome back, everyone. I hope you all had a hearty lunch. Now let's dive back into the remaining proceedings of the conference with a new zeal and vigor. Up next, we have the third scientific session. The theme for this session is Emerging Trends in Biological Science Research. This session will be chaired by Dr. Rizwan Khan and co-chaired by Dr. Ambar Palla. Dr. Palla is a faculty at the Department of Biological and Biomedical Sciences. May I please request Dr. Khan and Dr. Palla to come on stage to begin the third scientific session.
Thank you all. Thank you, Sadia. So in this, the first step that we have in this session is the invited talk, for which we had invited Dr. Rizwan Khan from Salim Habib University. I would like to first have a brief introduction of Dr. Rizwan Khan with you. Dr. Rizwan Ahmed Khan is a distinguished scholar and educator whose academic journey has been marked by notable achievements and contributions to the field of artificial intelligence. In 2013, he was conferred with a PhD degree in artificial intelligence from University Claude Bernard, Lyon, France, an institution renowned for its excellence in research and innovation. Following this milestone, Dr. Khan further honed his expertise as a postdoc research fellow at Laboratory, so I'll speak it in French, fellow at Laboratoire d'Informatique en Hommage System d'Information in Lyon, France. Currently, he is serving as the professor and dean of the Faculty of Information Technology at Salim Habib University. My former colleague at Salim Habib University, welcome. His dedication to teaching excellence was underscored by the Best University Teacher Award bestowed upon him in 2023, and he has garnered further recognition with his shortlisting by the HEC for a prestigious national level award. For 2 consecutive years, Dr. Khan has received the distinguished honor of being selected by the European Commission as an invited professor at University Jean Monnet Saint-Étienne, France. Saint-Étienne, France, yeah, it's been a while I have been in French. Dr. Khan's research interests are as diverse as they are profound, encompassing a wide array of subjects, including machine learning, computer vision, medical image analysis, explainable AI, and human perception. Please welcome Dr. Khan. Thank you.
Okay. Good afternoon. Assalamu alaikum. Actually, I don't like standing. Am I audible? Yeah. Oh, okay, I'll try. Here we go. Okay. Okay, check. Okay. So, after lunch, I will take you to the journey, a fascinating journey of AI. AI, if you don't know, seems like a magic wand. Usko hum hilayenge and things will be done. Right? This is what most of the students and general audience think, that this is what AI is. So I'll try to demystify a couple of terms, and then I will show what I have done in medical imaging using machine learning and AI. Okay, so this would be my agenda of talk. So I'll be a bit quick. I think we have 60 minutes and we have 3 more talks. Before I move forward, so this is my brief biography. So by training, I'm an engineer. I did computer systems engineering and did masters from NUST. After a couple of years spending in industry, I got Erasmus Mundus scholarship. If you know what is Erasmus Mundus, I don't know. Okay. So I spent 3 semesters in France and 1 semester in Norway, and that was in AI, basically. And that was back in 2007. And at that time, machine learning was called pattern recognition. Scientists have a knack of using different words to get more funding. So now it is called machine learning. Okay, so I did PhD and postdoctorate from Lyon. And in between, I spent a couple of months in Norway, where I also spent 6 months during my master's. And back 2017, I came back to Pakistan, and since then I'm working as a professor at Salim Habib University. Okay, so these are brief, my publications from health tech. Actually, before, like 6-7 years back, I was not working in health tech. I was working in computer vision, and I was working with facial expressions. But from 2017, since I came back, I started working in medical imaging. So you can see a couple of my recent publications are in breast cancer. And before that, I did something with ASD, autism spectrum disorder. These are something preprints, so they are under review. I will show some results from them as well. Okay, let's start. Artificial intelligence, is it a reality or a hype? But once you start reading from the newspaper, for me, they write it like it's some kind of a magical story going on. And if you don't demystify like exactly what is happening, it is kind of a myth, it's a hype. और अभी भी ऐसी कुछ चीजें आती हैं कि we are going to make a cyborg. We will have an artificial human coming up like after a couple of years. We are far from that, by the way. Okay. So if you are an avid reader of history, you will find text that fascinates how we can reproduce brain or intelligence. This has captivated all of us for centuries. And this is like a shadow of what happens in our brain. So we have more than 100 billion neurons in our brain and synaptic connections. And up till now, with the help of deep learning and neural network, we are able to recreate maybe 5% of it, not more than that. So this is the scale of problem we are trying to deal with. So just to understand the context from where AI is coming. So you have at the bedrock, you have all the basic sciences, including psychology, philosophy, mathematics, biology, physics, you name anything. That is the bedrock of it. And if you try to make computational model from those subjects, from those domains, then it becomes computational modeling of those subjects. So you have computational biology, let's say, computational neuroscience. And if you embed intelligence on those computational models, you are into the domain of AI. By the way, what is intelligence? Can anyone tell me what is intelligence? How we manifest intelligence in daily life? Exactly. We manifest intelligence through decision making. Do you know how many decisions we make every day? From morning till we sleep. Couple of thousands every day without thinking. This is our cognitive ability to take decisions. And decisions comes from experience. जब से बच्चा पैदा होता है, it gets experience. And in machine learning and AI, this experience, इसको हम कहते हैं कि it's the data. So data is equivalent to experience when you are into the domain of AI. Okay, let me move forward. So from AI comes the field of machine learning, which is a sub-branch of machine learning. I will let you know a bit more. And then this is something more of a hype, जो आपको newspaper में पढ़ने को मिलती है, neural networks. So deep learning is equivalent to neural networks. So this is the tree of knowledge that we have. Okay, so artificial intelligence actually starts with the aim of creating artificial humans. और जब humans की बात करते हैं, we have the robots. The only thing that differentiates between robots or machines from human is decision-making ability. So AI starts with this dream, but soon scientists realize that this is very difficult. So they come up with the idea of machine learning. So AI is top-down approach. Machine learning is bottom-up. They say, okay, AI is very difficult to get. Why don't we break the problem into smaller chunks? how we can create human visual system before knowing what is natural language processing. So it chops down the field of AI into smaller chunks, and this becomes machine learning. So it's the subdomain of AI. And subdomain of machine learning is neural network. So it's a part of machine learning, this neural network, but they have very specific structure. I will show you a few figures. Okay, so I have written a sentence. This is the hype. We have learned a lot about it, that it will exceed capabilities of human being or will displace humanity. Do you agree with this sentence? It's a very strong sentence. So here comes the fine division where there is reality or a hype. In newspaper, when you read something, it is something like this. Okay, we have achieved in some domain superhuman kind of accuracy, but humans are multitaskers. AI has done good only in one subdomain of it. We have human visual system, we have language skills, we can balance ourselves, we can run. There are a lot of other things that we do every day. Machine learning is good at only recognizing few objects at the moment. Okay, so they have beaten humans in one subtask, but not all. Okay? When media refers to term AI, usually they refer to what we call artificial general intelligence. So artificial general intelligence is about making artificial humans. Usually this is what they refer to. Okay, so they will have Terminator, Cyborg, they will come from, I don't know from where, and they will displace us. And this movie was 1980 something, right? Okay, we are getting closer, a bit more closer, but still it's very difficult to get till this point. What usually we are working is on artificial narrow intelligence. So general intelligence is making machine that is as good as human. Narrow intelligence is chopping down the domain and doing or getting good accuracy on narrow domains of it. For example, we are very good in translation, let's say. So this is chopping down the problem of AI. We all use Siri, right? If you are on Apple. If you are using Android, then we have OK Google, right? We have a recommender system. We have Netflix, Daraz, Amazon. So we are good at some task of it. For medical, we have CAD system. All of you know what is CAD system? Computer aided design, computer aided diagnostics. Okay, we'll see. Okay, so there are few examples of AI or machine learning. Now we'll start using machine learning where we have achieved very good results. So from this one, you can see that the system is able to track people, it can identify people, it knows what is the trajectory of person, where he or she is going. So if a surveillance person wants to track someone, they can do this thing, right? And this is actually, it's practically available in China, so they are tracking their population. This is part of my PhD and postdoctorate, where if I sit in front of a camera, it recognizes my facial expressions. So there are 6 prototypic expressions, but we have much more than those. But I only work with 6 expressions. And there was a problem of micro expression. I left it. This is something Tesla is working on, right? So if you have a system on a street, it recognizes every object. Here you cannot see, but each and every object is labeled automatically. So car can identify where to maneuver, where to go. This is, we do every day to unlock our phones, right? So this is again subdomain of machine learning, which is computer vision. And actually medical imaging is part of computer vision. This is kind of a negative example where we can put our words on some other face. And this is a big challenge to identify which video or image is fake or real. And we have achieved superhuman accuracy using machine learning. So that is a bit of a negative ethical issue with machine learning. And if you are into gaming, if you use Xbox or Sony things, so again, a domain of computer vision. Okay, this is something coming up these days. This is called generative AI.
Greetings, I am Professor Dr. Rizwan, the Dean of the Faculty of Information Technology, the Department of Computer Science at the Salim Habib.
This video is artificial. This is generated using only one image. I gave my image and gave the script, and this video was generated. Okay, right now you can identify, if you have met me, that I don't talk like this. But for a person sitting 1,000 miles away, probably he or she will think, okay, this is me. So this is generative AI. Another example of generative AI. So this is again artificial video.
Ready to create a dynamic AI-powered avatar? Let's make it happen with Midjourney, HeyGen, and ChatGPT. First stop, Midjourney. Design your avatar. Adjust, experiment until you're thrilled with the result. Got your avatar? Time for HeyGen.com. Navigate to the talking photo section and upload your avatar. Ready to make your avatar talk? Tap plus on your new avatar and it's time for a script. But wait, no need for the writer's block. Head over to ChatGPT and generate a script that suits your avatar. Copy it over, click submit, and boom. Your custom AI avatar is ready to speak for you in your marketing videos. Talk about hassle-free and stunning avatars in minutes. Remember, with AI...
Have you seen such videos on the internet? You can create your own video, your marketing video, maybe video for the university. This would be a nightmare for guys working in, video processing domain. We have graphic designers. But now even a novice can do that. And just the last one. I'll be quick.
Image generation models have taken the world by storm. It's now possible for anyone to turn their ideas into images using nothing but words. The explosion of creativity these models unleashed was years in the making. In 2021, Runway introduced latent diffusion, an AI system that was able to generate realistic images using an improved image generation technique. And in 2022, Stable Diffusion, a further improved version of latent diffusion that caused a tidal wave of creativity and...
Okay, you got the idea where we are heading. So it looks sometimes brighter, but someday you think we are going in the wrong direction as well. And by the way, there is a field called ethical AI. So we need to define those boundaries where AI can be used and what are the no-go areas. So this is the new field of AI, by the way. Okay, there are a few examples from medical image analysis. So I will play this video afterwards. So you have gait analysis. So if you put sensors on the body, we can train the system, and even without sensor, the person or the gait of a person can be recognized. Prediction of cardiomegaly, again, just with the help of a video system is trained, and then if an image or a video is given, which is not part of the data set, it still predicts. This is something I did in my postdoctorate, is the pain detection. So in the West, the problem is there are not many nurses or doctors available. So instead of a person attending the patient, they just put the camera, and just camera is looking on the patient, and when there is some sign of distress, it alarms that there is something bad going on. So this is the part of facial expression recognition. Skin lesion classification, breast cancer analysis, this is what I have done for a couple of years. And just one video this is a video from intensive care unit.
Michael Dieter has been awaiting a lung transplant at the University of Florida Health Center since December.
I'm what you call high flow air, and because of that, I can't sustain myself at home.
A dedicated team of doctors and nurses attend to him day and night. But that's not all. Sensors and cameras track Dieter's every move in this smart intensive care unit, from vital signs to facial expressions and everything in between.
Every place in this room will sense something about you. Is this enough light? Is this enough noise? Are you okay? Are you moving enough? Are you in your bed? Are you out of the bed? I think that's the future of how we will design hospitals.
More than 350 gigabytes of information per patient goes into a central computer, where artificial intelligence then processes the data.
We could look at the patient and go, they're moving a lot. There's something going on there. Or their face has a certain grimace to it that they normally don't have. Is it possible that it could tell you before I even know that I'm having problems?
Yes, 100%. We will be able to decipher complex features, complex emotions like agitation or hunger.
Funded by the National Institutes of Health, the high-tech experiment enters its 3rd year. Researchers are still teaching the technology what certain actions like sitting and standing might indicate. The hope that AI will soon be able to provide real-time healthcare recommendations.
Okay, let me move forward. You got the idea how we can use AI for different domains. Okay, so we are on the second part of my presentation, how it works. Just a brief description. I'm not going into the calculus of AI, right? So how children or humans learn? Any idea? Yes, experiences. So let's take an example of a kid playing with a toy car. And by the way, this is the image of my son, who is now 12 years old. So it's quite old picture. So he used to play with the small cars. And we never told that car can move. He was barely 8 months or 9 months. And since then, he started playing with it. So the thing is, we learn from experience. Our eye take image after every 200 milliseconds. So we have fixations and saccades, right? So we have 5 pictures per second. So if kid is playing with a small toy even for 5 minutes, how many pictures are stored in the brain? Can anyone tell me? Just in 5 minutes. So 5 in 1 second, 5 multiplied by 60, multiply by anyone? Around, maybe, right? And if you think the kid is growing, they're looking at the world from a different perspective. They're taking images, they're taking videos, they're listening to voices, they're trying to balance themselves. Everything happens with some time. हम देखते हैं ना बच्चा चलता है, गिरता है, then again stands up, again tries to walk. This is how we learn from experience. And this all number crunching is happening in our brain. We have 100 billion neurons. We have neural network. So as kid is learning, our neural network is getting trained for certain tasks. So neurons get fired for certain tasks. When they look at this car, they know, okay, this car can move. With the passage of time, they understand that it could be a mechanical thing. We can start it. If we pull it down, it goes forward. This kind of stuff. And okay. So machine learning, in machine learning, we try to mimic the same idea. So in machine learning algorithms are those algorithms that learns from data. And in machine learning, data is equivalent to experience for humans. We don't give explicit rules. We don't code it. Machine learning algorithm all provides as an output. I will show one image. An algorithm performance gets better with experience, as with the kid. As we grow up, as the kid grow up, they get better at all the tasks. So just look at how machine learning is done. So if your problem is, this is traditional computer science domain. So let's say if you want to find a mean of 10 data points, what you will do? You have X's, those data points, and then you will write a program to add them up, divide by number of, okay. I've been told that I'm running out of time, so I'll be quick. So we have X's, we write program, we get the output Y. In machine learning, this system is bit changed. So we have the data, we have the output, like medical image. We have mammograms, we know which mammogram is malignant, which mammogram has a benign tissue. So we know axis, the output here becomes an input. And machine learning system as an output gives those rules which we don't know, or patterns from the data. As this was a field of pattern recognition, it finds pattern from the data. And then once this is done, this is machine learning cycle. So you train your system, you have the data, you have the output, you train the system, you have this classifier and output, then you have unseen data point and you predict. So this is the cycle of machine learning. Okay, so This is a picture of biological neurons. So we have dendritic trees. It gets excited, and if it gets excited, it will fire, right? If action potential is zyada hoga, so it will fire. The same happens with artificial neuron. So can you see correspondence between this image, and this image? It's exactly same. So you get the input. It could be in the form of any data. It could be images, it could be videos, it could be your survey data, anything. You multiply with the weights, like in dendritic tree, you sum them up. If they're greater than some threshold, the neuron is set to fire. And then you make a neural network. This is a picture of neural network. So this is the input layer. You have many neurons. They combine, they learn. This is all mathematics. So I'm just skipping that. And at the end, you get the result, the prediction for certain class. Right? Okay. Okay. Let me move forward. So we all know what kind of modalities we have. We have X-rays, we have MRIs, we have ultrasound images, we know endoscopy, CT scan, PET scan. Okay. Okay, I can talk. I can keep on going. So the goal of medical imaging, or the goal is to analyze the data and help the doctors to help the doctors to get better diagnosis. It is not going to replace at the moment, but it is going to aid radiologists to have a decision. Okay, I'm just skipping that because I want to show. Okay, so this is the cycle of machine learning system. So you have data. It could be X-rays, it could be mammogram, PET scan, CT scan, anything, but we need lot of data. And lot means a lot. Because if you don't have data, then system doesn't learn anything. That's the problem with AI at the moment. You extract some features, or if you have the domain knowledge, you can define your own features. By the way, these are mathematical functions. Okay, so these are few features that we look into the image. So we have edges, we have gradient, a local binary pattern, texture, a lot of stuff we can do. Then we select the best out of those features because all features are not useful. And then we have classifier, machine learning system. So we have a lot of different classifiers. By the way, these are all we call function approximators. So they give mathematical function as an output. So they all give some kind of mathematical function. Okay. And then from those you get the possible output. Probably you would have mask of lung. You can predict whether the person has a pneumonia, COVID, or anything, right? So this is the brief cycle of machine learning system. So these are few results from my research. How far I am? Can I take 2 minutes? 1 minute? 1 minute. She's saying yes. Okay. Okay. So this is the recent result we have. So we have mammograms. We apply machine learning system, deep learning system. We extracted some features. This is the domain knowledge from the radiologist. We combined those features, and then we applied machine learning system to find whether there is a benign tissue or malignant tissue. Our results were like this. So this was the data set. I am just moving forward. This is the field of explainable AI. The problem of AI you cannot explain, and that's why doctors don't use it much, because we can't explain why the result is coming. So the domain of XAI tells why this decision is coming up. It could be in the form of heat maps. So it tells where the most important feature lies in this image. Okay, so I'm skipping the result. Okay, these are the results from XAI. So these are mammograms, and these are different methods of XAI applied on those mammograms. And the brighter the color is, it tells where the most important features lie in that mammogram. So that gives some kind of confidence to the doctor that, okay, whether the system is working fine or not. So sometimes it can be bad as well. Okay, this is something we did with autism spectrum disorder. So we have the data set. We segmented corpusculism from it. So that is corpusculism, which is the middle part of your brain, which connects left hemisphere with the right hemisphere. And we extracted some features from that. And we tried to find which features are probably the biomarker for autism spectrum disorder. This region was something important from our study came, which is written over here. I don't know what it is, planium or something. So maybe you know better. but these are the results from our study. Okay, this is what we did with X-rays. Maybe I can just show you this video, just a 1-minute video, and then I'll finish it off.
Is the symbiotic relationship between the human and machine that brings the magic of AI to medicine in a meaningful way.
Now we have the tools to make a huge difference to human life.
Cancer research is increasingly powered by data. Those data remain siloed across institutions.
We're creating a data ecosystem that allows people to share data and making sure that we're doing that in a way that still maintains the privacy of the patients.
With the power of AI, we can go after the unknown. And I can guarantee that we'll find something that nobody expected.
Sudden death syndrome scares every mother and father, and it is a problem. We have to change. The collaboration with Microsoft, AI for Health, will help to start this next step of our discovery. Our data show very convincingly clear correlation between smoking and SIDS, and just changing behavior can save children's lives. You cannot measure the benefit of that.
It's a sad day when the patient comes in and I can't impact them.
Through AI for Health, we will be building an AI solution that can autonomously diagnose diabetic retinopathy.
With the portable camera, I can take healthcare to the patients who would not be able to come to us. I want you to look right here.
Just to finish, thank you very much. Thank you.
Thank you so much, Dr. Rizwan. It was a very interesting conversation. In fact, not just sharing of data. Now I would invite